Let's take an example using the linear approximation. Let me just write it out one more time. The f prime at a, x minus a, plus f of a, where f, the function we're talking about, and a will be determined from the context of the problem. So let's just say I want to approximate something simple. Approximate the root of 4.5. The root of 4 is obvious. The root, right, it's 2. The root of 4.5 is not so obvious and difficult to compute directly. So we can try to use our linear approximation to the radical function at a place that's close to 4.5, or reasonably close, but yet we'll also know the value there. So in this context, I would let the root of 4.5 be the root of 4 plus 0.5. Right? I'm going to view this as my function of a plus delta x or dx. I'm going to write it. Okay? This is my comparison. In other words, I'm only moving a 0.5 distance away from a better value because I know the root of 4, right? So I'm going to view the 0.5 as being this discrepancy here away from the value a, away from 4, and the function is, of course, the square root function. Okay? So given that, I'm just going to write it directly. F of x is the square root function, and a is 4, and delta x is 0.5 in this context. Okay? All right, so now we'll just construct the tangent line, basically. We'll just construct the tangent line, again, special notation, but all it is a tangent line. Tangent line to the root function at 4. All right? So I need the derivative, so f prime of x should be, using a 1/2 power here, 1 over 2 root x. And I want to know that at x equals a. So f prime at 4 should be 1 over 2 the root of 4. This looks like 1/4. All right, so there's this piece, right? There's the slope of our tangent line at a for this root function. So we have 1/4 here. So now we see that the linear approximation of the root function at 4 will be given by this tangent line, which is 1/4 x minus 4, right, x minus 4, plus f of a. Well, I mean, we know f of a. F of 4 is root 4 is 2, which is why we chose a to be 4 in the first place, because it was an easy value to compute in this function. Okay, so we have plus 2 here for f of a. All right, so now we need to do, to approximate the root of 4.5, or really anything. I mean, 4.1, 4.3, 4. Something close to 4. I've chosen 4.5, doesn't really matter. Is now just to put in the value 4.5 into the tangent line function, into the linear approximation. Right? So I want to know what the linear approximation of 4.5 is. You'll note that when I plug this in, the x minus 4 here becomes nothing other than delta x itself. It's going to become 0.5. Okay? That should always happen. If not, you've made some sort of mistake somewhere. So we see this is just now delta x, or dx, however you want to write it. All right, so to finish the computation, 4.5 minus 4 is, of course, the 0.5 delta x. 0.5 times 1/4 should be pretty obvious, right? It's just a half. I'm going to write it as 1/2 here in a second, maybe. A half times 1/4 is an 1/8, and plus 2. So we see it's 2 1/8, which I guess as a decimal would be 2.125, I guess, right? 1/8 is 0.125, if I remember correctly. So we should have 2.125. So here's our approximate to the root of 4.5 using this particular technique. Okay? So the root of 4.5 is approximately 2.125 using this particular technique.